So I grew up in the age of Mercury, Gemini, and Apollo. That was what excited me as a young child. And I just fell in love with space exploration and, I guess all the excitement of leaving Earth and possibly going somewhere else to live. And of course, Star Trek was, a big new TV
Mhm.
show, and the Jetsons as a cartoon. Um, and so those are the things that really influenced me. Of course, as I matured, I decided that I really didn't want to leave Earth. that I was more interested in helping, to further exploration by working on spacecraft and things like that here. But
Okay.
my background, I graduated from the University of Virginia
Mhm.
with a degree in physics and chemistry. So I could never decide which I liked better. I would say for somebody that is trying to decide what to do, especially for a bachelor's degree, try to leave your options open. Follow your passion. And many times that means that you have more than one passion
Yeah.
that's going on. And so my first job was actually taking advantage of my chemistry degree and doing some drug chemistry work, encapsulating cancer drugs into these little things called micelles, so that you could up the dose that the body could actually handle and not be toxic. And then my forays then went into physical chemistry, developing infrared detectors, and then eventually getting into space operations using those things.
Wow. So when did you make that transition into going into space?
Pretty early, I would say probably within the first 5 years of
Mm.
graduating from UVA, and then it's been, I always said to myself that when I got bored with what I was doing, the types of jobs I was getting, that I would go back to school, and then I'd have a clearer idea of what I wanted to study. But I can tell you that I have never been bored. I never did go back to school. I've always been very fortunate to find my passion in the work and the jobs
Yeah.
that I've been doing. So it's been very, very rewarding. Um, yeah. So
So, okay, so you told me that you didn't want to actually go to space, but you just wanted to contribute to space. So, is that why is your mindset like that? Shouldn't, oh wait, no, not shouldn't. Like, is what kind of makes you think that you want to contribute and not actively move everyone to space?
yeah, I think the what I didn't understand about my passion about space was actually the engineering part of it. How do you make uh, components work in space? What are the challenges of, having communications out through space, and what kinds of things do you need to do that? And so for me, it wasn't that I didn't want to go to space. It was just that I found more interest in developing those tools and those processes that we would use while in space. And so that's kind of how I ended up doing actually robotic spacecraft,
Okay.
not being involved in the manned part of it.
Okay, so are you close with Dr. Alan Stern?
Yes, yes.
Like on a you can talk to him basis? Like
Yeah,
you're really close with him?
I've had a few meetings with him today already.
Wow. So okay,
Yeah.
what's his relationship to you?
So he's the principal investigator of the New Horizons mission,
Okay.
uh, and I am the mission operations manager or mom for New Horizons. So we work very closely together. We worked on the proposal. Of course, he worked on the whole thing, and my part of our contribution was defining how operations would look for a mission out to Pluto and beyond.
Okay, so typically, like for you as the mom of the New Horizons mission, which is really cool. So how does a typical work day look like for you?
With each part of the mission phase, it's different. So in development, we're doing a lot of testing. If we have any kind of issues, we're developing new tests to perhaps ferret out what the issues might be and how to solve those problems. When you're in mission operations, what you want to do is you want to be involved in the design of your spacecraft so that you can influence the design so that it's easier to operate post launch. The
Mhm.
last thing you want to do is have a very cumbersome operating system on spacecraft because it just makes it harder, and you don't need to if you can influence that design. Um, as you start to fly a mission, the first thing all spacecraft do is go through commissioning. So those days are long and mostly real-time commanding. I don't know how familiar you are with spacecraft commanding, but we can do real-time commands, whatever we send to the spacecraft is automatically immediately executed by the processors on board the spacecraft. We can also send delayed commands, which actually go into spacecraft memory, and then each command is time tagged. So as the onboard spacecraft onboard clock ticks down, when that time matches the time with that command, then that command is executed. And this is, vital for missions that are doing encounters and, things like that. So, we're developing command sets, we're testing them on simulators. So part of my day would kind of look like that. Of course, during the encounter, yeah, that's a whole other, you know, way to spend your day.
Yeah, so you mentioned the time tagged command. So I did a little bit of research. Now the RTLT is like the round trip light time, and I believe it's 55 or even more, 55 or higher. Um,
55.
AU.
Oh, yeah, we're probably at 62-ish or something AU.
Okay, how do you balance some of those time tagged command loads versus those real-time commanding with the 6 to 10 hour RTLT?
Yeah, so right now, the spacecraft is at about a 17-hour round trip flight time or RTLT. Um, so when we passed Jupiter, when the spacecraft passed Jupiter, which has a RTLT of about let's see, 90 minutes, I believe. We devoted a lot of our time to transitioning our commands from real time to time tagged or things that we can load in memory, because just as you say, there's nothing that you can do quickly for spacecraft. You want to have most of those commands to be time tagged executing out of memory. We do have, of course, when we load commands to memory on the spacecraft, we are uplinking in real time. We're loading them to memory,
Mm.
and then the commands will execute out of memory when the time is right for them. So, yeah.
Okay, so now could you walk me through like a recent activity where the autonomy or the fault protection did exactly what it was designed to do?
Um, sure. Let me think about what is a good one to do. So throughout the mission, we have had probably mm, on the order of a bit more than 10 what we call processor resets. So this is when the main computer will all of a sudden just sort of lose its way. And it'll what we call reset. So it'll reset itself. It's sort of like when your computer gets that little blue, that circle that goes
Yeah.
around and it's waiting to. So what happens then is that the processor resets itself, and then autonomy will command it to reload memory, reload from flash memory, and the spacecraft then, directed by autonomy software, will point to Earth and put out what we call low rate telemetry or safing telemetry. And our spacecraft, New Horizons, transmits that low rate telemetry at 10 bits per second. And the reason why you want to do this is because if your spacecraft is somehow has gotten off point, you have much more bandwidth on a 10-bit signal than you say do on a 500-bit per second signal or something like that. So you want to maximize the chance that you're going to intercept this signal. And then, so that gives you an idea of what the autonomy system will do. We haven't had one of those resets in a while, but those are the ones that we are most prevalent for us. But when you think about the mission is, what, almost 20 years,
Yeah.
10 or a handful of these types of things is not a lot.
Yeah. What exactly is beacon hibernation?
So the spacecraft right now is in a beacon hibernation mode, and it's a way to save lifetime on your components. So every component is when you build a mission for NASA, you are building to a certain lifetime, and that has to do with the mission objectives. So for New Horizons, it was on the order of 23 years. So what that
Okay.
meant is that we had to make sure that any components that we use, we test rated them to at least 23 years. And that was because a direct flight to Pluto, should we not be able to use Jupiter as a gravity assist, would take on the order of 23 years to get there and return the data. Um, so yeah,
The 23 years is just the time to get to Pluto
and return data.
and return data.
Yeah,
Okay.
yeah. Um, so yeah, what was your question? I'm sorry.
I was just asking about beacon hibernation, like
Oh
what it
yeah,
was.
beacon.
Yeah.
Yeah. So we have a very small team. So one way, and we wanted it that way. We wanted to kind of constrain costs because at the time that this mission and probably currently as well, you're competing with other proposals for NASA type missions, and we wanted to come in at a you know a low cost, but also a really cool mission. And so beacon hibernation was our proposal to have the spacecraft be in hibernation mode for part of its journey to Pluto.
Mhm.
And what that does is it lowers not only the resource usage for people, but it also it lessens the lifetime use on the components on the spacecraft, the hardware. And so what we did is when the spacecraft was in hibernation, the ground team was working on developing the set of commands that will accomplish the observations for the Pluto flyby. And so we were actually using, didn't have to have a separate team do that. So what the hibernation period does for us is that we have the autonomy software. We have 8 different tones that can be received by the Deep Space Network or the DSN. And so we took those 8 tones and we divided them up into levels of criticality. So tone 0 is what we define as a green beacon. It's not really a color, it's a frequency.
Mhm.
So it's just easier to say green.
Yeah.
And that just means that the autonomy system has not identified any issues on the spacecraft that need ground support or mission operations support. And then tone 1, we call that a red 1 beacon. And that would be, there is an issue on the spacecraft. It needs attention, but it's, not that dire. But the interest and progressively, this is how we clump the things. So when you get a beacon tone, you automatically know that this is the subset or the trade space of what might be going on on the spacecraft. So it
Mhm.
narrows, what you're now concentrating on might be the problem on the spacecraft. So it really gives you a good indication. Um, and so, then we know how to start preparing for the recovery of the spacecraft.
Okay, so if it's let's say it's a quiet it's some quiet months where there's not much really happening. I mean, it's just on cruise control like the mission. Is anything a lot different? Like do you kind of you kind of get to you're not too like it's not as nerve-wracking whenever it's in those quiet months. So does any what really changes for your group?
So when we are in an awake period, so right now we're in a hibernation period, and we will be in this hibernation period for about 320 days. So prior to entering the hibernation period, probably a week and a half prior, we had developed and tested a command set of commands that carry us through that whole 320 days.
Oh, okay.
When we're in an active period or awake, um, we are developing command sets that cover approximately a 2 week period. So the spacecraft is, say, executing some 2 week period. The planning team is actually working on the next set, finishing up the next
Mm.
set of 2 week period that we're going to load to the spacecraft. Our flight controllers are actually monitoring the spacecraft as we have different contacts, making sure that the command load is executing, that we're performing the science observations, that we're doing whatever that command set of commands is telling the spacecraft to do. All the while, we're reviewing any kind of past anomalies that we have or open problem reports. We're holding meetings. We're getting input from science team. We're getting input from our engineers. So there's actually a lot going on during an active or awake period.
Okay. Active or hibernation, right?
Well, active versus hibernation. Hibernation is we have this long period where the set of commands is already on the spacecraft and it's
Oh, okay.
so the planning team won't start to work on the next set of commands until we get probably 2 months prior to wake up
Okay.
period. So if we're waking up the end of June, then our planning team is going to start working, end of April, something like that.
Okay, so what's your philosophy on console authority and go or no go decisions?
Yeah. Um, yeah. So we the go, no go types of things that we do are for our command set. So the set of commands has to be prepared. It has to be reviewed by the stakeholders. So that what that means is that the science team, the principal investigator, the engineering team, of course, the mission operations team, and their go, the mom gives the final go, but their go is based on the simulations that have been run on the command load, making sure that those commands do what we intend them to do on the simulators on ground. If you're talking it has to do with the telemetry that we're receiving from the spacecraft in real time. So when we did our first correction maneuver at about 10 days after launch. And so when you're that close to Earth, there's hardly any time delay, right? And so those go no goes were based on real time telemetry data versus now it's based on the review of our simulations on what the command load's going to do.
Okay, so for like a couple of the final questions. So if let's say someone in the audience is a student and they're aiming for operations ops or systems at APL or NASA, what should they be doing to prepare themselves to get there? I mean, it can be anything from like the education or projects. What advice would you have to give for them?
Yeah. I think a passion for space is probably the first thing. Um, for mission operations specifically, I have a very diverse team with a very diverse background because we actually need that. We're really like systems engineers, and so you need those different disciplines for people to have. So when we have a problem, they can bring their different point of view and their different experience to the table. So I have electrical engineers, I have aerospace engineers, obviously. I have some astronomers. I just have a variety of people. So for mission operations, it's a background that contributes to space exploration, hardware, systems, things like that. I would say and it's pretty competitive now. Um, Although I think the commercial space has opened up a lot more opportunities than when I was, you know, getting into the space business. There was really only like NASA and,
Yeah.
some military stuff. Um, I would say that if there's any projects that you can do, like I know that a lot of universities have CubeSat kind of programs.
Yeah.
If you can get internships at NASA or at some of the commercial companies, I think that is great. Leadership experience, even if it is a summer camp, you're leading children, or you're at McDonald's and you're a manager. I would say leadership is a big one. Um, Being open, I think listening is hugely important. Because many times it's the quiet voice that comes up with the solution to a problem. So you need to make sure that as a leader, you're actually listening to everybody in the room and making sure everyone has that voice, because you never know what you're going to be presented with in mission operations and probably other engineering fields as well. But I would say those are probably the things that come to mind.